Hi there, welcome back to our review. This time, we're going to talk about the components of the atom, or what we know as the subatomic particles. So, remember that atoms are best described through different atomic models done by different scientists, and models have revealed the composition of an atom, and atoms are primarily made of three subparticles. Those are the proton, the electron, and the neutron. So let's start with the proton. It has an electric charge of positive 1. Again, it has an electric charge of positive 1. It is said to be stable by itself. Its location is found inside the nucleus, wherein it is located at the middle portion of the atomic structure. It is heavy, the reason why most of the mass of atom comes from here. The second is called the neutron, and it has no net electric charge. It's not positive, it's not negative, so there's no charge at all. Both this proton, the positive charge, and the neutron make up the nucleus of the atom. Nucleus, again, is dense and located at the center of the atom. Most of the mass of the atom comes from there. These particles are collectively known as nucleons, and, like what I said, located at the center of the atom. And the last is called the electron, and it has an electric charge of negative 1. So, based on the size, it is much smaller than neutrons and proton. It is found revolving somewhere outside the nucleus since its mass is approximately 1 over 1837 of the mass of the proton. So an atom is whole, but its various components and subsystems are dependent on each other for existence and function. An atom cannot exist without its components. So, likewise, a component cannot exist without the others. They are equally important. So, after knowing the different subparticles of the atom, this time we're going to determine atomic number and mass of the atom. So, mass of the atom is concentrated in its nucleus. Remember what I told you, because the number of protons indicate what element an atom is. So, therefore, if the number of proton is 1, therefore the atomic number of the atom is 1, and that is hydrogen. The number of electrons is equal to the number of protons. If we have 2 protons, we also have 2 electrons. They are or they have equal number. And that represents also the atomic number of a particular element. If that is 2, then definitely it's helium. So if electrons are removed from or added to a neutral atom, the same element will become a charged particle. Then ion will be formed. Like whenever they lost or they gain. Cation, when the ion with positive charge is formed when the electron is removed from the atom. That is cation. An anion with negative charge is formed when electron is added from an atom. Next, looking at the atomic number. It refers to the number of proton in an element as well as the number of electron. Symbol used for this to represent the number of or the atomic number is Z, capital letter Z. It also represents the number of electrons, like what I told you, and it serves as numeric identity of the element. Here is the atomic number depending on the table of elements you're using. Lithium got 3 atomic number, meaning it has 3 protons and 3 electrons. Then The mass number is 7. How are we going to get the mass number of protons? You have to add the number of protons to the number of neutrons located inside the lithium. Let's say in lithium, there are 3 electrons, 3 protons, and we have 4 since neutrons numbers are not fixed or not always equal to the number of protons and electrons. Once you add 3 plus 4, then you will get a mass number of 7. Next, atomic mass is based on the weight of protons and neutrons. We can say it's the sum or total, and the symbol that we use for that usually is capital letter A. So the same atom may have different mass due to the number of neutrons that they have inside their nucleus. Remember, the number of neutrons will not always be the same with the number of protons inside the nucleus. It may be greater than or less than the number of protons. Isotopes are at when an atoms of the same elements but they differ when it comes to the number of neutron. We call it isotopes. Example, we know that hydrogen has one electron and one proton. So we call it hydrogen 1. What if there is neutron already inside the hydrogen? So the mass number will increase because you add new or there's neutron inside the nucleus. Adding two neutrons inside the nucleus of the hydrogen will also increase its mass number. Again, we call them isotopes. So remember the formulas. If you want to find out the atomic number, always remember that the number of protons is equals to the number of electrons and always equals to the number of their atoms or atomic number. They are equal. Next, if you're going to look at the mass number, all you have to do is to add the number of protons to the number of neutron or neutrons. And if in the atom you don't know how many neutrons are there inside the nucleus, all you have to do is to subtract the atomic number to the mass number of the atom. So that's it for this day. I hope you understand the different subatomic particles of the atoms, the way we compare number of protons, electrons, and atomic number, the isotopes, and then how to get the mass number and the number of neutron. See you again next review. Bye bye.